Well, welcome back, everyone. Thanks for coming. This week we've been talking about building and evaluating prediction rules. We talked about how you could use a logistic regression model as the basis for predicting people's risks of developing some outcomes. We talked about how you could evaluate the performance of a prediction rule by measures that reflect the ability to discriminate or calibrate those risks with actual outcomes. And we talked about how you could evaluate those prediction rules in certain ways to get honest estimates, valid estimates of how well this rule might work in future people. Well, I'd like to end by giving you an example of a prediction rule. It's an example I do in a class every summer that I teach here at the School of Public Health. And basically, what it is the following. It's an exercise that I use in the class called EPI 208. That's a course that's designed to train mostly clinicians in the research methods needed to do clinical research. But I can tell you that course and its content is very similar to what I've been teaching in this course. So they've been taking and observing essentially everything that you've been seeing. What I've been doing is this exercise for essentially the last 10 years. I ask a series of questions to the students, which are potential predictors for some outcome that I want to predict. The outcome that I'm predicting is whether you are Canadian or not. Now, this is not meant to be offensive to any Canadian, our fine neighbors to the north of our country. Every summer, roughly 10–15% of our students in my class in EPI 208 are from Canada. They go along with this exercise. It's meant to be hopefully educational, but also it's a fun way to involve students in the creation of a prediction rule. So what do we have? We have data collected from 2003 to 2012, 10 years. I've got about 2,000 people now in this data set who have completed this data set over those 10 years. Each year I ask 20 questions to the students, questions that might be predictive of whether they're Canadians or not. Now, the important thing is when I ask these 20 questions each year, the students don't know the reason for this survey. I haven't told them yet that I'm using these as potential predictors to predict their chances, their risk of being a Canadian. That comes after the end of the 20 questions. Some questions are the same that are asked each year. Some vary a little bit from year to year because I ask the students to dream up their own questions. Once they know I'm asking whether you're Canadian or not, I give them the opportunity to nominate a few extra questions that we could ask to the class. So, but roughly speaking, I have a core set of about 15 questions that have been asked over the last 10 years. What I'm going to do is use logistic regression to build a prediction rule, like we've been talking about, predicting a person's risk of being Canadian. I'm going to use a forward variable selection algorithm to build that prediction rule. We talked about that in an earlier lecture. I'm going to let a computer program like Stata decide which of these 20 predictors should be included in this model by step adding predictors to a model, each step adding a new predictor that adds the most independent, incremental, statistically significant information on top of what was selected already. And to build this model, what I decided to do was to take my data set of these 10 years of answers to questions collected from students in my class and divide it into two pieces. One piece is going to be a training set. The training set is going to be everybody who completed the questionnaires between 2003 and 2011. And the testing set are going to be the people who completed the questionnaire the very last summer. So basically what I do each summer is take the existing data collected from previous years as the basis for building the prediction rule and use the current students to evaluate how well that previously constructed model from last year works among them. Okay, so let me first show you the questions that we used in this exercise. And actually, I'm only going to show you the questions that were selected by the variable selection algorithm. And there were 5 of them. And here's what they are. And I'm not going to tell you yet what the questions really pertain to because you might want to respond right now yes to no to each of these 5 questions to see what this model would give for your risk of being Canadian. I'd be curious how well it works among you. So the first question, and all these questions are yes/no questions, coded 1 if you had answered yes and 0 if you answered no. The first one is a dietary question. Have you ever eaten something called poutine? I'll tell you in a minute what poutine is. And in the next slide, you'll see the formula for the logistic regression model. And the name of the statistical variable that captures that 1, 0, that yes, no answer to this question is called P-O-U-T-I-N-E, poutine. The next yes, no question is, you ever had a Tim Horton? And I'm not going to tell you who or what a Tim Horton is right now. But again, it's a yes, no question. 1 if yes, 0 if no, and it's going to be coded as by the name of the variable Tim Horton. Next question. Have you ever stood in a lineup? Now, I'm not going to tell you what a lineup is supposed to be, because that term might have different implications for different cultures and different countries. But answering the best you can, yes or no, have you ever stood in a lineup? The next question is, do you think the beaver is a proud and noble animal? A beaver is a furry little creature. Lives around rivers, builds dams in those rivers made up of sticks and mud and things like that. Do you think that beaver, in your opinion, is a proud and noble animal? 1 if yes, 0 if no. And the name of that variable is going to be called beaver in the next slide. And then finally, do you consider minus 10C? I'm not going to tell you what C stands for, well, you probably do know. Do you consider minus 10C to be cold? 1 if yes, 0 if no. And we call that variable in the next slide. The yes, no answers that by the name minus 10C. So before I give you the formula, let me give you some detail now. Poutine. Well, if you remember a few weeks ago, we had a cardiologist, a friend of mine, Murray Middleman here, talking about cross-sectional studies. Murray is a Canadian. Murray is a Canadian cardiologist. Murray has said that poutine is one of their life-giving foods that they jokingly would recommend people taking, because poutine puts you at high risk of developing heart disease. It's made up of essentially what we call French fries, which are covered in some sort of a gravy. On top of that is some sort of a cheese curd. So jokingly, it's a type of food that could cause you to develop heart disease if you ate a lot of this. It's not a very healthy diet, but it's a very common diet in one part of Canada, the French-speaking part of Canada. Quebec province might find poutine a very common food. Tim Horton was a Canadian hockey player, a very famous Canadian hockey player. But at the end of his career, he started a chain of essentially donut stores. So a Tim Horton refers to a type of donut that's sold commonly throughout Canada. Have you ever stood in a lineup? Well, in the States, when you hear the word lineup, you think about people being arrested for some crime and being put in a viewing room where witnesses can try to come and pick out who they think is the criminal who committed that crime by looking at a series of people who are lined up against one another. So a lineup is part of a police investigation to try to find the likely culprit for committing some crime. But up in Canada, a lineup is just a line you stand in if you're waiting to, say, go to the movies or something like that. Do you think the beaver is a proud and noble animal? Well, in Canada, the beaver, I understand, might be their national animal, their symbol animal symbol of Canada. So Canadians would likely say yes to that question. And finally, minus 10C means minus 10 degrees Celsius. Now, in the States, we measure temperatures in Fahrenheit rather than Celsius. Many of us don't know what the counterpart in a Celsius is for a particular temperature measured in Fahrenheit degrees. Well, in Canada, they use the Celsius degrees, and they can tell you whether minus 10C is a very cold temperature or a warm temperature. 0 Celsius represents the temperature at which water freezes. So we're talking about a below freezing temperature. But Canadians might be very hardy people. They might tolerate the cold better, so we anticipate they might say yes, that it's not cold, more often than saying no compared to other people. Well, here is the model that I developed using the data collected from 2003 up to and including 2011, everything but this current year. This is the formula of a logistic regression model. Remember, we've seen this for a number of reasons in this class. What we're using it for now is to estimate a person's risk, P, their risk or probability of being Canadian. So what you could do, if you've answered yes and no to those 5 previous questions, you can plug in zeros and ones into your answers to those 5 questions about minus 10 degrees Celsius not being cold, or standing in a lineup, or thinking the beaver is a proud and noble animal, or eating poutine, or having had a Tim Horton. If you answered yes to all 5 of those questions, in other words, you put a 1 into the places for those 5 variables, multiplied those answers by the regression coefficients. And any number multiplied by 1 is just the number itself, which means if you answered yes to all 5 questions, your log odds of being a Canadian is going to equal the number 7.7037 plus 2.3238 plus 1.7318 plus plus 3.6930. You could add those up, and that would be your estimate of your log odds of being Canadian. You could turn that into an odds by taking e to that number. You could turn that odds into a risk using the method we talked about way in the beginning of this class. And if you do that, your estimate of being a Canadian, your value is about 98 or 99%. You're very, very, very likely to be Canadians. I'd be curious if each of you answered those 5 questions, figured out your risk from this equation, and in the chat room, tell me if your answers are not what you expected. In other words, if you were Canadian, let me know if your risks were very small. If you were not a Canadian, let me know if your predicted risks were very high. I'd be curious to hear some of your stories about this. But to give you a simpler way to use this formula, on the next slide, what I've done is I've ignored the fact that these 5 risk factors have different coefficients. It looks like it's much more predictive of being Canadian if you've had a Tim Horton with its coefficient of 3.69. Remember, that's a log odds ratio, compared to, say, whether you've stood in a lineup where its coefficient is only 1.7. So it is true in this model that different predictors are getting different weights, are influencing your risk more than others. But let's suppose for the time being we ignored that, and we just looked at the 5 questions that were being selected. And I asked you to just count up how many times you said yes. You could say no to all 5, so the total number of yeses would be 0, or you could say yes to all 5, your total number of yeses would be 1. And I could put you into groups according to how many questions you answered yes. Well, when I did that to the data that I had from in my 10 years of asking this to my students in the summer, I got the following tables. This is using just the training set, just using the people from 2003 up to 2011, not including last summer, and putting people into 4 different subgroups, depending whether they had either none or only 1 question to which they answered yes to, or answered yes to 2 of them, 3 of them, or 4 to 5. And what we have in the next column are the numbers of people who answered questions in that way to fall into those categories, and the proportions of them who said yes. So, for example, among the people who answered yes to none of the questions or only 1, there were 493 people. Only 2 of them were Canadians. So the training set is recommending or suggesting that those people's risks of being Canadian is 2 out of 493, or 0.4%. Very, very unlikely to be Canadian if you answered yes to only 1 or none of these questions. If you answered yes to 2 of them, any 2 of them, there were 106 such people, 9 of them were Canadians. That means that group has an estimated risk of 8.5%. Now, if you answered yes to 3 questions, any 3, there are 36 such people, 13 of them were Canadians. That's an estimated risk of 36% of being Canadians. And then finally, if you answered yes to 4 of the 5 questions or answered yes to all 5 of them, there were 61 students between the years 2003 to 2011 who fell into that category, and 59 of them, 97% of them, are Canadians. So you could use this table, a much easier table. You don't have to plug numbers into the logistic regression, multiply things, add them up, get a log odds, turn the log odds into an odds, turn the odds into a risk. You just have to figure out how many times you answered yes to these questions. You put yourself into one of 4 groups, and your risk could go from as low as 0.4% to as high as 97%. Now that's the problem, though. This is using the same training set for 2 purposes. To develop the model. Remember, we did a selection algorithm. We chose the 5 best predictors among all the candidate predictors in this data set to give us our logistic regression model. And now we're using the same people to describe how it's going to work. Well, I need a better way to estimate how it's likely to work in future people. But unfortunately, I have future people. I have the cohort of students from last year. That's my testing set. So the last slide is going to describe how well that model worked in those future people. So I have the same 4 categories of people, depending on how many times they answered yes to these 5 questions. The middle part is exactly what we had before, describing how well that model worked in the same people from which it was developed. We're worried that might be optimistic. And then finally, I want to draw your attention to last year's data, 2012. There were 122 people who took the class. Only 8 of them, unfortunately, were Canadian. So this is not a very strong data set in terms of numbers of outcomes. Even though we have 122 students, only 8 of them are being Canadians. But let's see how well our model worked. Among people last year who said yes to none of the questions or exactly one, there were 74 people, and none of them were Canadians. And that matches up pretty well. That 0% estimated risk is pretty close to the 0.4% that was predicted from the training set. On the other extreme, I have 9 people in this class last summer who answered yes to either 4 of the 5 questions or to all 5 of them. And 7 of them were Canadians. That's a risk of 78%. Not as high as the 97% that was originally thought to be their risk. But remember, this testing set only has 9 people in that last category. And Marcello's been talking to you in his lectures about precision of estimates and how the sample size drives that. Just imagine if you had 1 more person in this group. Instead of 9, you had 10. And if that person was Canadian, that 7 out of 9 would become 8 out of 10. It's growing up to be 80%. So if you grew the size of that group by larger numbers, you'll get a more precise estimate, and maybe it'll grow closer to the 97%. In between, I saw risks of 8%, 8.5%, and 36% in the training set. I saw 0 and 6%. Again, they were based on small numbers. But in general, I have a sense that this rule is doing very well separating the people who are very likely to be Canadians. If you look at it, among the 8 Canadians I had in the last data set, 7 of them are in that last group. So if you answered yes to none of one of these questions, I'm pretty confident that your chances of being Canadian is very slight. If you answered yes to 4 or 5 of these questions, my guess is very good that you are like a Canadian. So you could answer your questions the way you did, put yourself in one of these groups, and see how well that predicted risk sort of predicted your outcome. So you had 2 ways to package this prediction model, the original logistic regression model and the simpler table. I'd be curious if you have any comments on how well your actual outcomes to the question, are you Canadian, 1 if yes, 0 if no, matched up with either the predicted risks from the tables that I've shown you or from the formula for the logistic regression model. I'll be curious seeing your comments on our discussion board. Well, that's all I wanted to say about prediction rules. See you next time.